So I named the presentation How to Authenticate Toward Smart Contracts, and I want to start with giving a little context of what I mean by that. So the internet computer is a blockchain that is special in some ways, and one of them is that is scalable. So I just took a screenshot from our dashboard here, 23 blocks per second. Every single block can easily contain 1,000 or more transactions, depending a bit on the transaction size. And we're still scaling, so it's horizontal scaling. The internet computer is growing in capacity now every week. And with this scalability also comes a lower transaction price. So a single transaction only costs a fraction of a cent, which is very different from other large-scale blockchains. Another interesting property is that the internet computer can serve content directly into web browsers. No plugins, no extensions, just a plain web browser. And these two things together support a new set of use cases. You can think about, for example, social media served directly from a smart contract running on-chain into users' browsers. And the advantage of that is there's no single party controlling this social media anymore. There's no single party that has an incentive to exploit users' data. The entire social media platform could be controlled by the users. It could be fully decentralized. And there's also no intermediary needed to serve that content to users, because users' browsers can directly fetch it from the internet computer blockchain. But with these new use cases also come new requirements in terms of authenticating users and identifying users. And so that has to be solved quite differently from existing traditional web. So these are types of logins that you're very likely to know from the traditional web. The most widely used one is just username password authentication. Now that does have fundamental problems, just like phishing or password databases getting leaked, all this kind of thing. But it's even worse in a sense for a decentralized system, because the main methods of password authentication or checking passwords that are used in practice require the password to be in clear for the check. So either it has to be sent in clear or it has to be stored in clear. There are some advanced cryptographic solutions that ease that requirement a bit, but also they are not deployed. They're not that easy to implement and start. So in practice, we have this requirement of having the password in clear for the moment of the check. And that's, of course, a problem in a decentralized system where we need to assume that any particular node could be malicious, could be trying to subvert the system. If that node gets the user's password, pretty much everything is lost. So passwords don't really work for us. Then another thing that is used in practice quite often is sign in. I call it sign in with big tech. Like you register with any one of those big tech providers. You get a username from them, and you can use those as an authentication service toward other websites. And I think many users actually refrain from using that because of privacy implications. Like every single sign-on you're going to do is going to be visible to whatever major provider you're using. But I think in terms of decentralized systems, there's even a more fundamental problem, which is you're essentially delegating verification of your identity to one single entity. And whatever services you use your identity on, so the provider you're using could subvert your identity. They could impersonate you toward those websites you're using that service for. And that's not necessarily a problem if you trust that provider, but it also isn't very compatible with a decentralized system if we build a single point of trust in authenticating users. So that's also not really an option. So instead, what we build on is not a surprise for anyone working in blockchain, proper cryptographic authentication using digital signatures. But also there, like, user experience hasn't been exactly great, right? So we know lots of cases where people got their computers hacked, keys were stolen, they lost huge amounts of money, or cases where people protected their keys a bit too well, and then they lost access to the keys, and now they lost some $200 million worth of Bitcoin. So managing cryptographic keys is actually hard. So there's a good question of why do we think that using this type of authentication, which is a bit tricky on the user side, would be a good idea to use in a scalable blockchain that is supposed to be used by users that don't have any clue about cryptography, less than probably all those people here that lost their cryptographic keys. And the answer is what I'm going to describe in the next 10 or 15 minutes. It's what we call internet identity. And internet identity is based on three main technologies. The first one is web authentication, which I'm going to explain, but we use that to actually keep the user's keys secure. The second one is we're going to manage access through a CANISTER smart contract. So that's a decentralized way of managing the user's access to the system. And the third one is specific cryptography that I'm going to explain on a high level, which is based on threshold signatures. Now, before I dive into the technical contents, just wanted to ask you for a show of hands. Like, who of you uses a mobile phone or computer that has some way of biometric authentication, like fingerprint, Touch ID, Face ID, or Windows Hello or something? Okay, so that's vast majority. Who of you uses a USB security key, such as Nitro key or YubiKey or so? Okay, so if you showed hands, that means that you can use web authentication. Who of you has been using that? Who of you has been using biometrics or YubiKeys or so to log into applications via browser? Okay, so that's a bit less. So you already use web, with very high probability, you already use web authentication today. If you answered yes to the first question, you could use it. It's actually very simple. It just comes with your browser. So web authentication is a standard from the Dfinity. It's by now supported by all major browsers, all major operating systems. And the core idea of the Dfinity, or the core application of web authentication in the traditional web, is as two-factor authentication. So as a means to thwart threats like phishing or leaked password databases. And the way that web authentication is used is roughly as follows. So the user will still usually use their username and password as a first means of authentication to the platform. And then the web server will send a challenge, which is just some random bits. The user's end device will then give that to the user's security token, which could be, as shown here, an explicit USB device. It could also be a TPM, some secure chip built into your phone or computer. So that doesn't really matter. I've just shown it here to simplify the diagram. That security token creates a response that the user's device sends to the web server. So that means in order for this flow to work, we need user interaction. So usually if you have a YubiKey like this, you need to tickle it so that it would send the response. If you use your computer or phone, you need to show your face or touch the fingerprint sensor. And what happens inside this device is really just a digital signature. So this device has a digital signature key inside, a private key that you use for the signature. And it really just gets the challenge, signs the challenge, and sends it back. And so in the internet computer, we use a slightly different flow because in decentralized systems, the challenge doesn't really make sense. But for authenticating the messages that we send to the internet computer, all we need is that this thing does a digital signature, right? So that's all we need. It does some weird formatting around it, but at its very core, it's just that very basic cryptographic building block. And now what is really great about these types of tokens, these are usually also called FIDO tokens or FIDO2 tokens, that are used in web authentication. What's great is that they usually never let go of the user's key. So whether you have malware on your machine, whether you have a malicious operating system, that all doesn't matter. There's no way that the hardware, as long as it behaves according to specification, there's no way the hardware will let go of that private key. That, of course, is great for security. At least the worst of all attacks, which is leaking the private key, is properly prevented in that case. But this great property also makes things a bit difficult. Suppose we use the digital signature key to control a huge amount of tokens, and then it's on your phone, and you drop your phone into one of the beautiful Swiss mountain lakes. You may just have dropped a ton of tokens with it. So we can build on web authentication, but we cannot completely build on web authentication. What we do in addition is, as I said, we build on smart contracts. So internet identity is based on a smart contract that users can use to register multiple devices under the same identity. So this smart contract runs on the internet computer. It's controlled by the decentralized governance system. So it can be updated, it can be upgraded, we can release new features, but all these features need to be supported by the decentralized governance system. So when we want to add more functionality to the smart contract, which is developed in open source, everyone could contribute there, then we need to make a proposal to the governance system of the internet computer in order to upgrade this CANISTER smart contract. So there is no central control. It's fully decentralized. And as I said here on the user side, the user can now register the public keys of various devices under their identity record in the Internet Identity Canister. Which means if you control your phone, you can authorize your laptop to also be usable for authentication. And then you can authorize your YubiKey to also be used for authentication. And if you drop your phone into a lake, that doesn't really matter because you can just use any one of your other devices to remove your phone, buy a new one, and register the key of the new phone. And what is important here is that the only thing that is stored in the canister is a list of public keys. There is no additional information stored about the user. It's just randomly looking public keys. So in particular, even if you use biometric authentication, that's an operation that happens purely on the device. That information about your biometrics never ever leaves your device. Only a cryptographic key is used in the decentralized system. So in order to explain the final ingredient for internet identity, I need to explain a bit more about the internet computer. So the way we scale is by building parts that are usually called shards. In other blockchains, we call them subnets, that each build their own blockchain. So we can scale by adding more and more subnets. And each of the subnets, and this is very specific, each of the subnets has a threshold signature key, which means the subnet itself can create digital signatures. But the private cryptographic key that is needed for creating the signature is never ever stored in any one place. It only exists in a distributed way across all those nodes in the subnet. And it needs 2/3 of the nodes of the subnet to create a digital signature. The key is also generated in a decentralized way. So we run a protocol between nodes in order to generate this random cryptographic key. It never ever exists in one central place. It only ever exists decentralized in that subnet. And the advantage here is that a user can now, for example, send a request to any CANISTER smart contract running on that subnet, and that CANISTER smart contract can respond with a signed response. So in contrast to, say, Bitcoin or Ethereum, if you want to really for sure know the state of any particular, for example, smart contract in Ethereum, you need to validate the blockchain. You need to have a copy of the blockchain. You need to validate that the computation is correct. Only then can you be sure that whatever the smart contract responded was indeed what it should have responded. Here it's different. Here all you need to validate the correctness of a response is you need that threshold key. You need one cryptographic key and then just the digital signature. And that's it. That makes it a lot easier to actually validate information that comes from the internet computer. And that may seem subtle at first, but it has profound implications. So just think about possible applications. One Dieter mentioned yesterday. There can be a smart contract that runs on the internet computer that actually holds Bitcoin. And that's not red Bitcoin with an intermediary sitting somewhere. That's the smart contract effectively holding a cryptographic key distributed across the subnet is running on. And that cryptographic key can be used to sign transactions on the actual Bitcoin blockchain. So there's no wrapping. It's really direct cryptographic integration. Or think about a X509 certificate authority running in a smart contract, providing certificates that can be validated by browsers, like without any additional software. again, just a smart contract doing digital signatures support these types of operations. Or think about documents signed by a smart contract. After some specified condition is met, maybe a certain number or a certain group of people has agreed to sign, maybe it's about time to sign, maybe the Bitcoin value reached a certain limit and now the contract signs the document. Like, multiple things are possible, and before I let you go off in your imagination of what you could build on these functionalities, I want to show how we use them in Internet Identity. So the idea here is that the Internet Identity Canister also has access to such a threshold signature key. And now a user, using their devices, using their web authentication keys that they have on their devices, they authenticate toward the Internet Identity Canister smart contract. And the Canister smart contract will then sign a message and send it back to the user. And this message will be usable for the user to authenticate toward other smart contracts running on other subnets on the internet computer. And this flow may look familiar to you if you know SAML, pretty old protocol, but still useful for single sign-on services, for example. This is a very similar flow. In SAML, this signature from the identity provider is called an assertion. If you know OpenID Connect, it's a slightly different protocol flow, but kind of the same idea, and they call this thing a token. If you know Kerberos, the very, very old authentication solution, that's called a ticket. So the flow itself is pretty well known. It's a bit specific for us because we bind to a cryptographic key on the client side instead of just having the token alone as being valid. That's just due to how we then authenticate the messages that the user sends to the subnet, because we don't have a stateful connection, we only process signed transactions. Good. So that's pretty much all I wanted to say today. Maybe to add two more things here on internet identity on the development side. I already mentioned that is open source, but also there's no need to actually use internet identity if you don't want to with the internet computer. It's just one solution that you can use for authenticating towards smart contracts. We think it's a good solution. We think it's a great solution. But if you don't want to use it, there's no harm. You don't have to. There's other solutions. Fleek provided the plug wallet, for example. You can use those solutions as well to authenticate to smart contract if that's what you prefer. And the third one is the internet identity canister that we build is purely based on functionality that is available to any smart contract on the internet computer. So if you want to build your own with improved functionality and give that to the world, great, just do so. It's all built, as I said, on functionality that is publicly available. It's not a central component or anything like that. We, of course, want to go further with internet identity. So one thing is, web authentication works great for users that have devices that support it. But it seems that, especially in some parts of the world, that's not always a given. And right now, those users cannot use internet identities. So what we want to improve is ways to preserve security, but also support devices without web authentication. We want to improve privacy protection. So right now, we have privacy protection under kind of strong assumptions, and what we want to do is we want to be able to weaken the assumptions we have to make in order to have a good privacy protection for the users. But that requires better cryptography on the authentication side. And we want to support better means of account recovery, because right now it's all bound to your devices. If you only have two devices and you lose both, you lose your account. So we want to build mechanisms that are based on identity verification, so that if you are able to validate your identity, you would be able to recover your account. And finally, interoperability with standards outside of the IC. So what we've built in internet identities so far works great within the internet computer. It does not really work that great right now with the ecosystem outside of the internet computer. So that's also one aspect which we want to improve. Yeah. That's all I have for today. I think I may have a minute for questions, if there's specific questions. Otherwise, I'd be happy to take them in the end. Mm-hmm.
Does that mean that through the we will finally be able to retrieve our data where they go and to allow companies that they want to use them or even sell our data?
Sorry, I didn't grab that.
Sorry. I was asking, through Dfinity, we'll finally be able to retrace where our data goes and allow companies that they want to use our data or even sell our data to them. This will be the big security we can have, and we can check where our data goes, because we know nowadays we are the product, and we get nothing in return.
So first of all, we try is here to minimize the data that we have in the system, right? So we try to not ever collect data that we don't absolutely need, like cryptographic keys, which we need. So I don't see this as a solution right now for managing personal data. At least that's not where we think we want to take internet identity in the short term. But it's imaginable that one could build a similar service that takes these aspects into account. We make an NFT for that, and you can retrace everywhere. Right. Although, I mean, it's kind of interesting. Also, if you want to sell it, it needs to be secret before you sell it, right? At least to know where it goes, and to allow a company or not to allow to use your data. Right. But for this, I think you always need confidentiality for the data in the first place. And so right now, the data we have sits on the blockchain. So the nodes that process these transactions, they see that data. So the data that we have is currently not private. That's why we absolutely try to minimize whatever we can. In that sense, I think it's still kind of an endeavor to build such a system where you actually have that data private, because where you collect data in a way that is private but still sellable. It's not in scope of internet identity right now.
Thank you.